We move on to the question number 11. Here we determine whether two figures are similar. The first part is to write similarity statements, which is very easy and very straightforward. Now look over here. They have told this is similar, and we have to list all the congruent angles and write the proportion of the corresponding sides. Now, how do we see that? How do we write the angles which are congruent to each other? Look, whenever two polygons are similar, these two are similar, right? Look, if I have a triangle, if I tell it's similar to this triangle, obviously this is not equal to this. Similarity does not mean it's equal. Similarity means characteristics are similar, in the sense angles are all same. Now easy way, like what I usually say is, now imagine there are two twins. Okay, two twins, they're identical twins. Okay, they're same identical twins. They are congruent, in the sense they're equal, they look same, look alike, everything is same, identical, they look just the same thing. They are called congruent. Okay, now if you have siblings, one is older, one is younger, they may not look the same, they are different sizes, but they have same characteristics, family name and many other things, so they are similar characteristics, they are called similarity. This is only similar. Now when you have a big triangle, big polygon and small polygon, you can see they're not congruent, they are just similar. So don't think that the sides are all same. No, only the angles are congruent. Angles are congruent, that means angles are equal over here. Now if it's A, this is A. If it's X over here, B, they're equal, like that. How do we understand? The easier way is, they have given the similarity statement. See the first. That is A, angle A is congruent to W. Whereas B, second one, will be congruent with the second one over here, that is X. Same way, C will be and D, you can write it by yourselves, will be congruent to C is with Y and D with Z. This is the congruent statement. Now don't write the lines. See, look, AB, the line AB, the first two will be with first two, right? Don't write AB is congruent to WX. This is wrong. The sides are not congruent. They are not equal at all. Looking at this figure, you can tell AB is bigger than WX. They are not congruent. But they are proportional, in the sense you can consider any one side first, any one polygon first. I'll take this as 1, this as 2. So now what you have to do is consider these two sides, AB, divided with AB means the corresponding side will be WX. That's the thing. This will be equal to, take any other two side, that is BC, that will be corresponding with XY, and lastly CD must correspond with Y and Z, and last we have AD or DA. It depends on how you write. If you write DA, write Z and W divided by Z and W. This is the corresponding sides proportionality. You can see this is the answers. Now over here, A is with W, B is with X, and that's the thing they have mentioned over here. And A is congruent to W, B is congruent, and so on. But the proportionality, even you can take WX first, it's fine. If you take WX first, all these must be on the top, this would be on the bottom. So that is the thing. And you can see over here, the same thing what we got. Okay, here we have taken DA, that's fine, ZW, or you can take it as AD, WZ. That's how we solve this particular problem. Very simple. And now there are more problems on the same concept, so please make sure you solve it by yourselves. Here, pause the video and do it by yourselves. I hope you tried. We will look into the answers. See the M with R, N with S, P with T, and Q with U. And the proportionality will be Mn. You can consider anything up. If you consider Rs, then divide by Mn. So we Mn is first, then Rs. So all the first, this polygon will be first only, up above itself, all the dimensions. Whereas this will be down. That's it. Even over here, the triangle, same thing. Please do it by yourselves. You can easily see it's very simple, very straightforward. Pause the video and look for it. If there's nothing new in this, I'm sure you must get the correct answer here. Same thing over here. Please make sure you solve it up, and you can pause the video and check it out. This is also very straightforward. There's nothing trick or nothing unique about this. It's very, very simple. Again, same thing. Is that all the problems same? Now, here, just be careful. Don't look into the figures because they are tilted, right? It's better you just focus on the given similarity A, B, C, D, F, G, H, J. So you can see AB by FG, BC by GH, CD over here with HJ, CD, yeah, this is all same, and AD with FJ. So that is the thing. And now this one is inside the small triangle is inside. Now this is similar. Why? Because we have we have proportionality over here. Whenever you see triangles like this, they are always similar. Now what you do is similar because of various postulates. You can take SAS or AAA postulate as well. Angle, angle, angle. All the angles will be equal, right? Now because this is parallel, and this is over here given. So just look at this, given one. Triangle MNP is similar to QRS. You can use the figures as well, but it might lead into confusion. If you're very thorough, it's fine. You can directly use the figure, but it's better to use this given statement and write this. Just focus here. MN over here, right side is QR, NP, RP, and so on. That's it. Okay, now we have some values and we have to find the scale factor. Now what happens is we were writing the proportionality, right? Just a while ago. So what that proportionality says is if it is similar, then all these scale factor must be equal. But first we need to find whether it's similar. How do we do it? Find the angles. We know 90 degree matches. Okay, what about the other two? See, is this similar? No, the angles are different. This is different. So, no, this is not similar at all. You can't proceed at all. See, the angles do not match. Wait a minute, they have told one. No, none of the angle match. Z, oh, only with this, sorry. Z and K, yes, that's 90 degrees. But you can see W and M or W and L, none of these match. So it is no, the triangles are not similar. That's it. Here, now let's look at this one. Here, what do we have? This is equal to this, and these two sides are equal. That means this is two equilateral triangles. This is a similar triangle, okay? You can see over here, they are using the corresponding angle theorems. We know WXZ will be equal to YXZ. See this one, this angle and this angle is equal. Fine. And from this, what else do you know? See over here, this and this is also equal. Another way to understand is if you take this W, Y, and Z, you can see this will be an equal isosceles triangle, right? These two are equal, so these two angles will be equal, and then obviously this also will be equal. Or now from your corresponding angles, you can say this angle will be equal to this angle as well. And then if all the angles only these are remaining, so obviously that is also equal. So this triangle and this triangle are corresponding to each other, okay, are similar. So now what you do is sides. They have already told us this side WZ and ZY are equal. But now if this is equal, what happens exactly? Because they are equal, WZ divided by ZY, they are equal. It's basically WZ divided by WZ itself. It is equal to 1, isn't it? That's the thing. So all the others must be equal to 1. All the corresponding sides will be equal to 1. Now here, that's what is written. Here, looking at this now, this triangle WX and Z is similar to this. There are different ways to, because see, this is 11, you don't need to go in detail. I will tell you one more way. Looking at this triangle, now this and this is equal, so obviously this and this will be equal, and then the third angle will be equal. Now otherwise, understanding this two, Over here, this corresponding will be equal, so that is up, because from the isosceles angle triangle property, that also can be used. Various properties can be used. Now these both are corresponding sides, isn't it? Now these are equal to 1. We know all the other corresponding side must be equal to 1, but how would you prove that? See, now x and z is the common side for both. That's the same side, x and z. So this is the common side for both. That will also be equal to 1. Okay, and then over here, what is remaining? We are remaining with this and this part, and that is also equal, because that is all the this, then it'll be an equilateral triangle basically. So that's the thing. And the scale factor over here was 1. We found it out over here. The scale factor is 1. So directly looking at this, we can write it. Now over here, now these have been given over here. The values are given. So it's very, very easy. Find the scale factor by dividing any two sides. These sides, just divide it. All the angles are equal. So obviously this is similar, no doubt. Okay. All the angles are equal. Now, angles are directly straightforward. You can write them. And what can you do is, for the scale factor, see these two and these two. Do they match? Only if they match. Now these are not matching, right? Look, they're not matching. So these are not similar. I just realized I told it is similar. It is not similar. It is angles are all equal. Okay, so that is the first part of similarity. All the angles are equal, yes, but the sides must be proportional. Now, if at all, if two polygons, all the angles are equal, but the sides that we write, right, AB and MN equals CD divided by XY, like this, if they are not equal to each other, if they're not proportional, then it's not similar. These are not similar. Now basically over here you have 2 8, so divide anything. 8 by 2, that is 4. This must be the same thing. 10 by 4 must be same. No, 10 by 4 is 2.5, which is not possible. That is, they are not similar. Let's think over here. Let's see the similarity. Looking at them, we can't exactly say, but we can say this angle, this is 90 angle, so the angle, this is vertically opposite. Yes, all the angles are congruent. That is done. All angles congruent. Now how would you solve the sides? So first of all, we need to know the order as well. This C both of it as B over here. If you write F over here, and then if you write D over here, G over here, this similarity statement. But now we are not sure whether this is similar or no. So what you do is take any two sides. I will consider DB, sorry, divided by, if I take DB, it should be GF, this one. Let's see, is it 4 divided by 20 by 3 equal? I'll simplify this. 3 goes up over here. Wait, 1 time 5 times, it'll be 3 by 5. Now I will take BC divided by FC. Substitute the values. What is BC? 5 divided by what is FC? 25 by 3. 1 time 5 times 3 goes up, 3 by 5. Very good. Like, what's the remaining? DC is remaining. DC by GC. What is DC? It is 3 divided by 5. Yes, all the three scale factors are same. The scale factor is 1, and yes, they are similar. So this is the similarity thing. If you check all that, you will easily get it. Now, if you're getting confused with direct methods, put in the calculator. You can get the answer, okay? So that is correct, and that is the final problem. So just try to practice more problem. Try to understand the statements, okay? That's very important. All the angles must be equal for it to be similar, but still there must be, the sides must be proportional. Only then it's similar. Otherwise, it's the same shape, same polygon, angles are equal, but it's not similar to each other. So just be careful with that, and then you can easily solve it up.